Good morning, everyone. Today we're going to look at another calculus problem from the Chapter 5 practice test. This time it is the shadow problem, so let's have a look-see over there. So we have an Alexis who is 5.7 feet tall, probably around 5'6", 5'7", I think. No, maybe a little taller than that. Anyways, she's walking at a rate of 5 feet per second towards a street light that is 20 feet above the ground. At what rate is the length of her shadow changing when she is 10 feet from the base of the light? So, as with any problem that we do, first we're going to try to understand it. Secondly, we're going to try to write some equations that govern what we see here mathematically. So maybe it's a good idea to look at a diagram of the situation. Here's our diagram. We have our Alexis. She's walking away from that light, and we can see her shadow on the ground down here. And a couple things to notice, which are important. Firstly, we have a right triangle. Actually, we have two right triangles. We have one right angle right here, so our blue triangle is a right triangle. We have another right angle over here, so our orange triangle is a right triangle. And secondly, both of those triangles have a vertex in common, which is this one right over here. So if you'll remember from geometry, asimilarity says that when two triangles have two congruent angles, the two triangles are similar. So let's take a look at those two triangles kind of dissected from each other. We're going to mark up our two angles so we know that these two triangles are similar. And then we're going to mark sides that we know. Alexis, her height is 5.7 feet. The street lamp is 20 feet. We know that the distance between, we don't know how long Alexis's shadow is, so we're going to call that x. And we know that the distance here's x again. The distance that Alexis is from the street lamp is 10. So when you put these two things together, you get that the length or the distance from the base of the lamp to the tip of the shadow, that is 10 plus x. And so with our similarity, we're going to say that the vertical height to the horizontal height, in the case of the street lamp, that's 20 over 10 plus x. And in the street of Alexis, or in the triangle with Alexis herself, that is 5.7 to x. And those two ratios are equal to each other because the triangles are similar. Okay, so now we have our equation almost. Maybe we should do a little bit of multiplication to get an equation without denominators, a non-rational equation. And I think I'm making a mistake here. Take a look at this. The distance between Alexis and the lamppost is actually changing. So I'm actually breaking some rules here by making that a constant. This should be another variable since it is changing. We're going to call it y. And then we're going to redo our similarity. Okay, so that's better. Now you know that I'm doing these videos live-ish. I think we can simplify this just a little bit. Maybe we'll move everything over to the left side of the equal sign. There we go. Everything is on the left side of our equal sign. And I'm going to take that equation, let's put it in a place that's a little bit more conspicuous, and continue the math there. Our equation is in place. Our next job is to differentiate both sides with respect to t, or time. Like always, first I'm going to show you that I'm going to take the derivative, and that's going to give us time to take a look at the variables and consider. We're taking a derivative with respect to x, or with respect to t. This variable is x, so I'm going to need a chain rule derivative there. This variable is y, so I'll need another chain rule derivative. And of course, the right side is just 0. So the derivative of 14.3x with respect to t is the derivative of 14.3x with respect to x, which is just 14.3, multiplied by dx dt, minus the derivative of 5.7y with respect to t is the derivative of 5.7y in terms of y. So in terms of y, the derivative is just 5.7 multiplied by dy dt. And of course, the derivative of 0 is 0. So Alexis is walking towards the lamp. So y is decreasing, which means for us that dy dt is going to be a negative number. And we know that number, that's going to be 5 feet per second. So now we'll substitute our negative 5 into our equation, and let's see what we get. So 14.3x prime plus 28.5 is equal to 0. Now it's a pretty simple solve. X prime is equal to negative 1.993. So that's our value of dx dt. Remember, dx dt is the rate that x is increasing or decreasing. So since x is the length of her shadow, we can write our summary now. So when Alexis is 10 feet from the lamppost, her shadow is decreasing at a rate of 1.993 feet per second. And that kind of does it for this one. Really short video, just one question. And it's a pretty classic question, the lamppost. I think I've seen it in every calculus book I've looked at. So enjoy. See you next time.